Now, before we go on to actually talk about how to determine the validity of standard form categorical syllogisms, let me do a little review. Remember, we had an argument like this: everyone who is 18 years of age or older is eligible to vote. My brother John is older than 18, so he can vote. And we identified the premises and the conclusion for this categorical syllogism. And then what we went ahead and did was translate each of these statements into a standard form categorical statement. So the first premise became all citizens 18 or older are citizens who can vote, and the second premise became all people identical to my brother are citizens 18 or older, and the conclusion became all people identical to my brother are citizens who can vote. Okay? Then after we made sure that these were all translated into standard form categorical statements, we went ahead and identified the various terms. So we have the minor term as the subject of the conclusion, the major term as the predicate of the conclusion, and the middle term, which is the term that's shared by both of the premises. Okay? And we also made sure that our premises are in the correct order. So major premise at the top position and minor premise in the second position, the middle position, and then the conclusion here at the bottom. So now this is in standard form, okay? So we've taken the ordinary language argument and put it into a standard form categorical syllogism. Then we are able to identify the form or the structure of this argument by removing the content and maintaining the quantifier, copula, and the variables that represent each of the terms. However, we also did provide a dictionary, okay, to show what these variables represent. And we've identified the mood and figure. This one is AAA1, okay? Now, after we've identified the form of the standard form categorical syllogism, we can move on to go ahead and determine the validity of the standard form categorical syllogism. Now, when we're talking about the validity of the standard form categorical syllogism, remember what we're talking about is the quality of the reasoning that's in that deductive argument. Remember, the reasoning of deductive arguments can be differentiated into valid or invalid, okay? And valid deductive arguments are those deductive arguments in which the reasoning of that argument fulfills the author's intent that if the premises were true, then the conclusion cannot be false. And invalid arguments fail to fulfill this intent, okay? So invalid arguments are arguments in which if the premises were true, it's still possible for the conclusion to be false, okay? So these are the valid and invalid reasoning in deductive arguments. And standard form categorical syllogisms will be valid and invalid based on the structure of their argument, okay? And this is actually the case for all deductive arguments. It's the structure of that argument which tells us whether or not it's valid or invalid. And it actually has nothing to do with the content, the truth of the actual statements themselves, okay? And we'll discuss this a little bit further when we get into evaluating these arguments, okay? One way that we can actually evaluate the validity of standard form categorical syllogisms is by the Venn diagram method. And we've actually done a little bit of the Venn diagram method for just diagramming the information in standard form categorical statements in earlier lessons, okay? This time we're going to add a few more rules to Venn diagramming so that we can actually use the Venn diagram method to determine whether or not an argument is valid or invalid, whether or not that deductive argument has good reasoning or bad reasoning. So what's a Venn diagram? Okay? A Venn diagram is a visually intuitive method of determining the validity of standard form categorical syllogisms. Okay? And here are the rules for following the Venn diagram method, okay? So you want to start with 3 interlocking circles, each representing one of the 3 terms in a standard form categorical syllogism, the S, the P, and the M, okay? Always diagram only the premises, okay? Never diagram the conclusion, and then always diagram within the circle representing the things denoted by the subject term of the premise being diagrammed. So you're going to diagram one premise at a time, and when you do the diagramming, you want to make sure that you do all your work in the subject circle of the premise that you are diagramming, okay? Also, you always diagram any universal premise first, okay? So any A-type statement or E-type statement will always be diagrammed first. If you have only universal statements, then it doesn't matter which one you diagram first. If you have only particular statements, then it doesn't matter which one you diagram first. But if you have premises where one is a universal and one is a particular, you want to always make sure to diagram that universal statement first, okay? Then universal premises are diagrammed by shading what does not exist according to the premise that is being diagrammed. And particular premises are diagrammed by placing an X in the area where the statement asserts that at least one thing exists, okay? So now these rules are very similar to the rules that are given when you're diagramming categorical statements. The one difference is that this time you're working with 3 interlocking circles rather than 2 interlocking circles, okay? And also, you have 2 statements that you're diagramming, so you have to determine which one to diagram first, universal statements first, if you have both a universal and a particular statement. However, these last 2 rules are specific to doing Venn diagrams of arguments, okay, specifically categorical syllogisms, okay, or standard form categorical syllogisms. So if there are 2 areas in which an X can be placed, okay, then you place the X on the line that divides those 2 areas, okay, and if there is only one area in which an X can be placed, then place that X in that one area, okay? And I'll explain a little bit further what these 2 rules mean, okay? So let's start by just doing examples of how to do Venn diagrams. And we're going to go ahead and do first a logical analysis of this argument, which is to determine whether or not it is valid or invalid. Then we'll work our way through to truth analysis, as well as analyzing the argument as a whole in terms of a deductive argument. So the first step to Venn diagramming, we want to draw 3 interlocking circles. So I'm going to use 3 different colors, okay? This circle will represent my S circle, my subject term of the conclusion, which is the minor term. This circle will represent my P circle, which is the predicate term of the conclusion, which is the major term, okay? Then this circle here will represent my M circle, which is the middle term, okay? Now that we have these 3 interlocking circles, notice that we have several spaces that are carved out by the interlocking of these 3 circles. And you can do this for yourself if you'd like to, if it makes it easier for you. I'm doing this so that it's easy for you to see what I'm talking about, okay? So here we have area 1, and in area 1 we have only those things that are S. And here we have area 2, and in area 2 we have those things that are S's and P's, okay? And here we have area 3, which is those things that are P's, okay, and just P's. Here we have area 4, which are those things that are P's and M's, okay? And here we have area 5, which are those things that are S's, P's, and M's, okay? And here we have area 6, which are those things that are S's and M's, okay? And here we have area 7, which are those things that are just M's. So notice here we have 7 different areas that were carved out by interlocking these circles. Okay, now that we've carved out the spaces, we want to diagram just the premises. When we look at our argument here, and we can just do this by looking at the form of the argument, and that's actually the easiest thing to do because then we don't have to think about the content, okay? Both of these premises are universal statements, okay? So the major premise is all M are P, and the minor premise is all S are M. So it doesn't really matter which one we diagram first. So I'm going to go ahead and diagram the major premise first, and the major premise is all M are P. Okay, I'm going to write it a little bit bigger here. And I'll do this with the black marker. So all M are P. Okay, so that's the major premise, and this is the premise that we're going to diagram first. Okay, so we want to find the circle that represents the subject term of this statement, which is basically the M. Okay, so all our work is going to go inside the M circle, not in the S circle, like out in this area, or in the P circle, but anywhere that's in the M circle, even those areas that overlap with the S and the P circle. But in any case, it's still going to be inside the M circle because this is the subject term of the statement that we are diagramming. Now this statement says all M are P. Okay, so it's saying that all those things that are M's are also P's. Okay, so what does not exist according to that statement are those things that are M's but not P's. And this is what we want to shade away as not possibly existing. So here's an M here that is not a P. Okay, so we want to shade that area away. So this is area 7. Okay, and this stuff, basically by shading it away, we're saying that they do not exist. Okay, and also notice here we have area 6, that's S and M, but not P's. Okay, so these are also M's that are not P's. So we want to shade that area as well. Okay, so the only area that we have left then is area 5 and 4 inside the M circle, where you have a M that's a P, so here you have an M that's a P, and also here in area 5 where you have an M that's a P as well as an S. Now it doesn't matter if it's also an S as long as it's still an M and a P, okay? So that's our diagramming of the major premise. And now we want to diagram the second premise, which is our minor premise. And the minor premise is all S are M. Okay? Now, here, the subject term of this statement is S. Okay? So we want to do all our work in the S circle now. Okay? Now, this statement says that all S are M, which means the only things that can possibly exist that are S's are those S's that are also M's. Okay? So what does not exist according to this statement are all those things that are S's but not M's. So because those things that are S's but not M's don't exist according to the statement, we want to shade that away. Okay? So notice here in this area 1, we have things that are S's and only S's, which makes these things that are S's and not M's. So these things don't exist according to this statement. Okay? And notice how we have here this area, S and P, area 2, where you also have things that are S's but not M's. Okay? So this area 2 also does not exist according to the statement because you have things that are S's that are not M's. Okay? So we want to shade that as well. Okay? Now notice how here we also have shading that's already been done by shading the first major premise. Okay? And that we're going to leave alone. What is shaded has been shaded and that just remains shaded. Okay? So we've gone ahead and diagrammed both our premises, and now based on this diagram we want to determine whether or not this argument is valid or invalid. And how do we do that? Well, we want to look at our diagram and see whether or not the diagram actually contains the information that's contained in the conclusion. Okay? You don't diagram the conclusion. What we want to know is, by diagramming the premises, do we also end up getting the information that's in the conclusion? If the answer is yes, then the argument is valid. If the answer is no, then the argument is invalid. Okay? So look at our conclusion. The conclusion is, and we're not going to diagram the conclusion, but we want to just look at the conclusion. The conclusion is all S are P. So we want to look at our diagram here to see whether or not it's the case that all those things that are S's are actually P's. Okay? And notice how the only area that's left in the S circle, okay, is this area here, area 5. And all the things that are in that area that are S's are also P's, because in the area 5 we have things that are S's, P's, and M's. Okay? So this, in fact, is a valid argument, okay? Because we have information that's in the conclusion that's contained in the Venn diagram where we've only diagrammed the premises, okay? So this is a valid argument. So logical analysis, analyzing the reasoning of this argument, tells us that this argument is valid. It has good reasoning. So if the premises were true, then the conclusion would definitely be true. Okay? It's impossible for the conclusion to be false. Now we want to ask, well, are the premises actually true? Okay, and this is actually truth value analysis. So remember, logical analysis is distinct from truth value analysis. Okay, logical analysis tells us whether or not the reasoning is good or bad. Okay, so for deductive arguments, we want to know, is the reasoning valid, good, or is it invalid, bad? Okay, and this has nothing to do with the actual truth of the premises. For evaluating the reasoning of deductive arguments as well as inductive arguments, we want to know if the premises are true, okay? Do they support the conclusion? Specifically for deductive arguments, we want to know if the premises are true, do they guarantee the truth of the conclusion? If they do, then it's valid. If they don't, then it's invalid. Now, besides evaluating the reasoning of the argument, we also want to ask, are the premises actually in fact true? Okay, and this is actually not logical analysis but truth value analysis. Okay, so we can go ahead and ask, are these premises actually in fact true? Okay, so we have the statement, our first premise, all MRP, and all MRP actually represents the statement according to our dictionary here. All citizens 18 or older are citizens who can vote. Okay? Now we ask ourselves, is it actually true, and looking at the context in the United States, that all citizens 18 or older are citizens who can vote? And this is actually true. So our major premise is actually true. Okay? And now we want to ask, is our minor premise true? All S are M, which also actually represents the statement, all people identical to my brother are citizens 18 or older. And we're talking about my brother John, and it is in fact the case that my brother John is 18 or older. So the statement, all people identical to my brother John are citizens 18 or older, is actually also true. Okay, so the minor premise is also true. Okay, so now we have an evaluation of the argument as a whole. Okay, so we take logical analysis and we take truth value analysis to tell us whether or not the argument as a whole is a good deductive argument or a bad deductive argument. Because this argument is both valid and has all true premises, this is a good deductive argument. So as an argument as a whole, this is a sound argument, okay? Which means that the conclusion is actually true, okay, given this argument, okay? Not only are the premises actually true, but the reasoning is so good that if the premises were true, it would guarantee the truth of this conclusion. So because it is the case that the premises are true, and it's valid, this is an argument that does guarantee the truth of our conclusion, and as such, it is a sound argument, okay? It's a good deductive argument as a whole, okay? Let's move on to another example. Okay, here we have another example, and once again, we're working here with the form of the argument. So we've gone ahead and done all the things necessary to translate a categorical syllogism into a standard form categorical syllogism and then reduce it to its form. But again, we still have a dictionary that is given to us here that tells us what each of the variables represents. And let's start with the logical analysis using the Venn diagram. Okay, so we want to draw 3 interlocking circles, and this time I'm going to try to draw the circles a lot bigger. Okay, so here is our circle that represents the S term, okay, which is the minor term. Here is our circle that represents the P term, which is the major term. And then here is the M circle, which represents the middle term, okay? And Once again, I'm going to write inside the spaces to kind of carve out and let you see what each of these spaces represent, but I'm not going to do the numbers this time, I'm just going to do the letters, okay? So in this area over here, we have things that are just S's. In this area over here, we have things that are S's and P's. In this area here, we have things that are just P's. In this area, we have things that are P's and M's. In this area, we have things that are P's, M's, and S's, okay? This area, we have things that are S's and M's, and here we have things that are just M's, okay? So we have 7 spaces again. And we want to now diagram only the premises again, and when we look at our premises, notice that we actually have one universal statement and one particular statement. The major premise is sum M are P, and that's a particular, and the minor premise is all S are M, and that's a universal. So we want to make sure to actually diagram the universal premise first. So we're going to diagram the minor premise first, which is all S are M, okay? Now, once again, we want to find the circle that represents the subject term of that statement that we are identifying, and that's going to be the S circle in this case. And because this is a universal affirmative, we want to go ahead and shade everything that does not exist according to this statement. So this statement, all S are M, are saying all the things that are S's are M's. So what does not possibly exist according to that statement are those things that are S's and not M's, okay? So we want to shade those things that are S's but not M's away. So here we have an area where we have just S's. They're not M's. So we want to go ahead and shade it away. It does not exist according to this statement here that we are diagramming, okay? Then we also have this area here where we only have S's and P's. So this is another area that represents things that are S's and not M's. So we want to shade that away as well. Okay? Now the only areas that's left in the S circle are all those things that are S's as well as M's. So here you have S's and M's, right, in this area here. And here in the middle, you have things that are S's and M's as well, but they also happen to be P's. And it doesn't really matter if they're also P's as long as they are also S's and M's, okay? So we only have things that are S's and M's left in this S circle, okay? Now that we've diagrammed the universal premise, we want to go ahead and diagram the particular premise. So the particular premise is sum M are P, okay? And once again, we want to do all our work in the subject circle of the statement we are diagramming. So this is a statement we are diagramming, and in this case, the subject circle is M, okay? So we want to do all our work in this M circle. Now, because this is a particular statement, what we want to do is use an X, okay, to represent that at least one thing that exists according to this statement, okay? So this statement says sum M are P, okay? Which means that at least one thing exists that's an M and a P, okay? So we want to go ahead and go to the M circle and find areas where you have an M and a P, okay? And notice here you have actually 2 areas. You have here a place where you have P's and M's, and you have here an area with P, M, and S. Both of these areas are areas where you have M's that are P's. Now, according to this statement, there's at least one thing that exists that's an M and a P, okay? And we have 2 possible places then where we can put that 1x. We can only put 1x, okay, for each particular statement. Well, where do we put the x? Because there are 2 possible spaces that exist where we can put this x, we don't know which area that x actually goes into according to the statement. So the statement doesn't actually give us enough information to determine whether or not that at least one thing that exists that's an M and a P goes here or here. So because this statement does not give us enough information, we put the x on the line okay, that separates the two areas where the X could have gone, okay? So here's the P and the M area, and here's the area that's PMS. And because the X could have gone either here or here, and we don't know which area it actually goes to, we put the X on the line that separates the two areas, okay? So on that red line here, okay? And I'm going to go ahead and re-diagram this without the letters and such so that you can clearly see where that X goes, okay? Okay, so I'm going to use blank ink in this time. So here's our S circle, here's our P circle, and here's our M circle. I'll use black to do the shading, and then I'll use red to mark the S, okay? So all S are M, okay? Means that all the S's are M's. So what does not exist are those things that are S's but not M's, okay? So those areas don't exist, okay? Because this was an area that was just an S, and this was an area that was an S and a P. So those two are areas that are S's but not M's, and they do not exist because according to this statement, all S are M, all the S's are M's, okay? So we have only left here in this S circle all the things that are S's and M's, or those things that are S's, M's, and P's. And remember, it doesn't matter if it's also a P, okay? Then we have some MRP, okay, which means there's at least one thing that exists. That's a M and a P, okay? So we want to go to our M circle this time because that's the subject of that statement, okay? And notice how here in this area we have things that are P's and M's, and here we have things that are S's, P's, and M's, okay? So we have two possible areas where that X could go. And because we have these two possible areas where that X could go, we put the X on the line here that separates the two area, okay? That divides those two areas in half. And we put it right on that line, okay? So this is the diagram of our argument that we have here. And now we want to know whether or not this is a valid or invalid argument, okay? And to do so, we want to look at the conclusion and see if the conclusion is actually contained in the diagram that we have after diagramming the premises. So the conclusion is some S are not P, okay? So in order to see whether or not the conclusion has been diagrammed, because this is a particular statement, and for all conclusions that are particular statements, what you want to find is an X inside an area where this statement says something exists. You don't want to find it on the line. You want to find the X inside the area where the statement says something exists, okay? So some S are not P means that there's an X, at least in one area, okay, where it's an S but not a P. So we look at our subject circle here, okay, and we want to see in that subject circle for this statement, some S are not P, the subject being S, okay. In this subject circle for this statement, some S are not P, do we find an X inside an area where something is an S but not a P? And notice how we don't, okay? This would be an area where it's an S and not a P, because this is an S and M area, okay? So this would be an area where it's an S and not a P, but there's no X there, okay? Also, there's this area right here that is the area SPM, and we don't have an X inside this area as well. However, even if we did have an X inside this area, this argument would still be invalid. And the reason for that is because what we need is an X that's inside an area where some S are not P. And in this area here, this is an area where you have some S's that are P's, okay? So here you have S, P, and M. So even if there was an X in this area, it would be an invalid argument. So this is actually an invalid argument. Okay? Now, given that it is an invalid argument, what this argument has is bad reasoning, bad deductive reasoning. If the premises were true, it would not guarantee the truth of our conclusion. Okay? Now that we're done with logical analysis, let's move on to truth value analysis. Now again, this is where we actually ask, is it the case that the premises are actually true? Okay? So we have the statement here, some M are P, and that's the major premise. And the major premise is actually asserting, because M is alligators and P is horses, some alligators are horses. And this is actually false. Okay? So we know here that the major premise is actually false. Okay? And then we have the minor premise, all S are M, which actually asserts all elephants are alligators, and we know that this is also false, okay? So it's not the case that all elephants are alligators. So the minor premise is also false, okay? So now in this case, we have an argument as a whole that is unsound. Okay, so it's a bad deductive argument as a whole. Why? Two reasons. One is that it's invalid, so the reasoning is bad, and also all of the premises are false. Okay, so it both fails in logical analysis as well as truth value analysis, so this is a bad deductive argument. It is unsound. Okay, let's look at another example. Okay, now here we have another example of an argument, and again we are working with the form here, so we've gone ahead and done everything we needed to do in order to get the form of the standard form categorical syllogism, okay? And we're going to go ahead and do the Venn diagram in order to figure out whether or not it's valid or invalid for logical analysis, okay? So, 3 interlocking circles again. This is the S circle. This is the P circle. And this is the M circle. Okay? And I'm going to go ahead and mark out the areas with the letters. So this is just S's. This is S's and P's. This is just P's. This is P's and M's. Okay? This is just M's. Okay? This is S, P's, and M's, okay? And this is S's and M's, okay? Now, we have here for the two premises, no P or M for the major premise and no S or M for the minor premise. So notice that both of these are universal statements, so it doesn't really matter which one we diagram first, okay? So I'm going to go ahead and diagram the major premise first. And the major premise is no P R M, okay? And we're going to go ahead and locate the circle that represents the subject term of this statement, which is the P circle. So this circle here, and we're going to do all our work in this circle, okay? And this statement states that no P R M, okay? So what does not exist according to this statement are all those things that are both P and M. Since no P or M, those things that are both P and M does not exist. So we want to shade those things that are both P and M. Now here we have things that could possibly be P and M's, and also in this area as well where there's a SPM. Since this area represents those things that can possibly be P's and M's as well as S's, okay, it is an area where something can be a P and an M. So we want to shade both of those areas. They do not exist according to the statement no P or M. Okay? Then we have the second minor premise, no S or M. Okay? So the minor premise is no SRM. And now we want to do all our work in the area of the subject circle for this statement, which is the S, so in this circle here, okay? And this states that there are no things that are S's and M's, since no S's are M's, okay? So we want to shade all those things that are both S's and M's, because according to the statement, those things don't exist, okay? So here we have an area where it's unshaded, and this is an area where it's an S and an M, okay? And so we want to go ahead and shade that, because that does not exist according to this statement, no S's are M. Now we also have this statement here, SPM, which also is an area where you have S's and M's. But because we've already shaded it when we shaded our major premise, okay, we don't need to shade it again, okay? It just remains unshaded, okay? So that's what happens when we diagram these two premises. And now we want to check, is it the case that this is a valid argument or an invalid argument? And to do so, we want to look at the conclusion, okay? So the conclusion in this case states that some S are not P, okay? So what we want to look for is an X, because it's a particular statement which asserts that at least one thing exists, that is an S, okay, but not a P, okay? So we want to find an X inside the S circle, okay, that doesn't overlap with a P. So here's our S circle here, and notice that there's no X's at all, okay? So there's no X in here, and there's no X in here. So this is invalid, okay? Because we don't have the information that's contained in the conclusion being represented in the Venn diagram after diagramming only the premises, okay? So this is also an invalid argument. Okay? Now that we've done logical analysis and we've determined that the reasoning of this argument is bad reasoning because it's invalid, we want to go ahead and do the truth value analysis, okay? So the first major premise states that no P are M, and in this case P are horses and M are alligators, okay? I've shortened it as gators. So this major premise asserts no horses are alligators. And this is actually a true statement, okay? It's not the case that there are any horses that are alligators, okay? So no horses are alligators is actually a true statement. So the major premise is actually true, okay? And then the minor premise, no S are M, okay? S's are elephants and M's are, again, alligators, okay? States that no elephants are alligators. And this is also true as well, okay? It is the case that no horses are alligators. So the minor premise is also true, okay? So here we have an argument that is invalid but has all true premises, okay? However, because it is invalid, even though it has all true premises, this is still a bad argument, so it's unsound. Okay? Remember, in order to have a sound argument, a sound deductive argument, a good deductive argument, it has to be the case that you have both valid reasoning and all the premises are true. Okay? So if you don't have either one of these or neither of them, then it's going to be unsound. It's going to be a bad deductive argument. So because this has invalid reasoning, even if it has all true premises, it's a bad argument. Okay? So the truth of the premises in this case will not guarantee the truth of the conclusion because the reasoning is invalid. The premises, if they were true, would not guarantee the truth of the conclusion. Okay? So this is an unsound argument. So here's another argument. Some MRP, all MRS, and the conclusion is all SRP. And once again, we're going to do logical analysis first, and we're going to use a Venn diagram to do this. 3 interlocking circles. and this area represents S's. This is S and P's. This is just P's. This is M's and P's. This is S, P, and M. This is M, and this is S and M. Okay? Okay, now we're going to look at our premises and notice how one of them is a universal statement and the other one is a particular. The major statement, sum MRP, is a particular, and the minor is a universal, all MRS. So we're going to go ahead and diagram the universal statement first. You always have to diagram the universal statement first. So the universal statement, which is the minor premise, is all MRS. Okay? We're going to locate the circle that represents the subject term of the statement we are diagramming, which in this case is the M circle. And we're going to do all our work in that area. Okay? And we're going to shade, because it's a universal statement, everything that cannot possibly exist according to that statement. So all MRS states that everything that is an M is an S. So what cannot possibly exist are all those things that are M's but not S's. Okay? So we want to go ahead in the M circle, shade away all the things that are M's but not S's. Okay? Here we have an M that's not an S, and here we have an M that's not an S. Okay? So we're going to go ahead and shade away these areas. Okay? Now we want to diagram our particular statement. Okay? Our premise, which is a major premise, that is a particular statement. And that particular statement is sum MRP. Okay? And sum MRP, remember, it is a particular statement, so we want to use an X to diagram, and we want to do all our diagramming again inside the subject circle for that statement, which is M. So again, in this M circle. Okay? And we want to place that X inside the area where that statement says something exists. Okay? So this statement says there's at least one thing that exists that's an M and a P, since sum M are P. Okay? So we go to the M circle and we look for the areas that are open to us that have things that are M's and P's. Okay? And we want to put an X in that area, unless there are two possible places to put that X. Okay? So here we have one area that's an S and an M. Okay? So that's not an area we're interested in, because we're looking for an area that's an M and a P. Okay? And we have this area here that's an S, P, and M. This area then is an area where you have things that are P's and M's. Okay? Although they are also S's. But it doesn't really matter if they're also S's, because that still means that there are P's and M's, because this is an area that's an S, P, and M. Okay? So because we only have one area open to us, we put our X inside that area. Okay? Right in there where you have now that at least one thing that is an M that's also a P goes in this area here. Okay? The only area left in the M circle that's open that has both P's and M's in them. Okay? Now once we've diagrammed the particular statement, okay, we want to go ahead and see if this is a valid or invalid argument. Okay? And we want to do so by seeing if the diagram of the premises includes the information that's contained in the conclusion. Okay? And the conclusion is all S are P. Okay? So what we want to look for, okay, because the conclusion is all SRP, is that the S circle shows that all the things that are S's are in fact P's, which means that there are no things that are S's that are not P's. Okay? So if we look at the S circle here, which is the subject circle of our conclusion, okay, we see that it's not the case that all the things that are both S's but not P's have been shaded away. Okay? So Notice how this is an S that's not a P, and this is an S and that's not a P, and these haven't been shaded away, which means it's not the case, according to this diagram, that all the things that are S's are P's, okay? We still have things that could possibly just be S's and things that can possibly just be S's and M's, okay? So this is an invalid argument as well. Okay? So now because it's invalid, okay, it contains bad deductive reasoning. However, we still want to know, well, are the premises true? So we want to do truth value analysis, okay? Now, the major premise reads some M are P, okay? And in this case, M stands for reptiles and P stands for lizards. So here, the major premise is stating that some reptiles are lizards, okay? And this is actually a true statement, okay? So lizards are types of reptiles. So our major premise is actually true, okay? And then our minor premise, all M are S. So M stands for reptiles and S stands for cows, okay? Our minor premise then says all reptiles are cows, and this is actually false, okay? It's not the case that all reptiles are cows. So our minor premise is false, okay? Now, when we look at the argument as a whole then, bringing together truth value analysis and logical analysis, this is going to be an unsound argument, okay? It's unsound for two reasons. Number one, it has bad reasoning, so it's invalid. And number two, one of the premises are false, okay? Specifically the minor premise, okay? So this is an unsound argument. The truth of the premises would not guarantee you the truth of the conclusion, and one of the premises is actually false, okay? Okay, so let's look at another example, and this is going to be our second to last example for doing Venn diagrams, okay? So here we have another argument, okay? And we, again, reduced it down to its form, and we have a dictionary. And we're going to do 3 interlocking circles. And I went ahead and showed you what each of these areas represents. Okay, so let's go ahead and diagram our premises. Now, our premises are the major premise, some P are M, and the minor premise, no S are M. And notice here we have one universal statement and one particular. So we're going to diagram the universal statement first. That universal statement is no S are M. Now we're going to go ahead and do all our work in the circle that represents the subject term of this statement, which is the S circle, okay? And this statement says no SRM. So what does not exist according to this statement are all those things that are S's and M's, okay? So here in the S circle, we have this area here that represents things that are S's and M's, so that doesn't exist. And this area here that represents things that are S's and M's. Okay, it also happens to be a P, but we don't really care about that for this statement. Okay, it's still an S and an M. Okay, so we shade that as well. Okay, now we move on to our particular statement, which is some PRM. Okay, and we want to do all our work in the subject circle of this statement, which is the P circle right here. Okay. And this says that there's at least one thing, which we represent with an X, that is a P as well as an M, okay? So we want to look at the P circle and find an area where you have something that could possibly exist that's a P and an M. And in this case, we only have one area where that's the case, okay? So we put the X inside that area, Okay, there's no other possible spaces in this P circle where something could exist that's both a P and an M. Okay, so that's our minor premise. And now we want to know whether or not this is a valid argument. Okay, and to do so, we look at our conclusion, which is sum S R not P. Okay, and we want to see whether or not there is an X, okay, at least one thing that exists that is an S inside the S circle, okay, that is not a P, okay. So notice how inside this S circle we don't have any X's, okay. We don't have any X's here where there would be an S, one thing that exists that's an S, that's not a P, okay. We have the X over here, however, this area does not represent something that is an S and not a P, okay? It represents something that is a P and an M, okay? So because we don't have an X inside this S circle, which is the subject term of our statement, where something exists where it's an S but not a P, this is invalid. Okay, so the information that's contained in the premises, after diagramming it, we can see that does not also contain the information given by the conclusion. Okay, so it is invalid. Okay, now we can also do truth value analysis again, and in this case we're asking, are the premises actually true? So the major premise is some PRM, and P is lizards and M is reptiles. Okay, so this statement is saying that some lizards are reptiles, and that's actually true, okay, because lizards are types of reptiles. So the major premise is true, okay, and the minor premise says no SRM, okay, so S is cows and M is reptiles, so the minor premise is saying that no cows are reptiles, and that's actually true as well. No cows are reptiles. So the minor premise is also true, okay? Now, this argument, even though it has two true premises, so all the premises are true, the reasoning is invalid, okay? So because of this, because the reasoning is invalid, it is not a good deductive argument. So it is, again, unsound, okay? So here we have an unsound argument where you have true premises but invalid reasoning. The reasoning is poor. So the argument as a whole is unsound. It's really important for you to understand that truth value analysis and logical analysis is distinct, such that you can have a bad deductive argument, an unsound argument, even if you have all true premises, okay? And the reason for that would be because the reasoning is bad, okay? Remember, when an argument has invalid reasoning, it is an argument where even if the premises were true, they don't guarantee the truth of the conclusion, okay? So because even if you have true premises, the reasoning is such that even if you have true premises, you don't have the truth of the conclusion guaranteed. This is a bad deductive argument, okay? It's unsound. So here's our final example of doing a Venn diagram for determining the validity of arguments, okay? So here we have an example where its major premise is some PRM, the minor premise is some MRS, and the conclusion is some SR not P. Okay? So again, we're going to draw 3 interlocking circles. Okay? And I'm going to identify what the areas represent. Okay. And now if we look at the premises here, we notice that both of the premises are particular premises. Okay, so it doesn't actually matter which premise we diagram first. I'm going to go ahead and diagram the major premise first. The major premise is some PRM. we're going to do all our diagramming inside the P circle, which is the subject circle of the statement we are diagramming. And because this is a particular statement, we're going to use an X, okay, to place inside, okay, the area where something is a P and an M. So we go into the P circle and notice that there's actually two possible places now where we can put this X. Here's a place where it's a P and an M, as well as here where it's a P and an M as well as an S. So because there are these two possible areas open, we're going to put the X on the line, okay, that separates those two possible areas. Okay, now we want to move on to our next premise, okay? And our next premise is another particular statement, and this is sum M R S, okay? So again, we want to put an X inside an area where this says something exists, and in that area that we're specifically concerned with is the M area, which is the subject circle of the statement we're diagramming. And this says that basically at least one thing exists that's both an M and an S. Okay? So we look at this area here, and notice here again we have two possibilities. Here's an area inside the M circle that is an M and an S. Okay? And again in this middle area here, it's not shaded away. Okay? So it's still a possible area. We have things that are S, P, and M's, which are also things that are S's and M's. Okay? So this X, according to this statement, sum M R S, could go in here or in here in this middle area. And because we have the two possible areas available to us, we are again going to put the X on the line that separates the two areas, which is then this green line here. Okay, so that's what happens when we diagram the minor premise. Now we want to know whether or not the argument is valid or invalid. Okay, and the conclusion is sum S are not P. Okay, so what we want to look for is an X inside. Now remember, when you're looking at conclusions, you need to look for X's inside areas for particular statements, okay? So we want to find an X inside the subject circle of this statement, which is now the S circle, okay? Where something is an S but not a P, okay? Now inside this subject circle, okay, if the conclusion were to be diagrammed, we would have to find the X inside this area here where it's just an S, so that's an S but not a P, or in this area here where it's an S or an M, where it's an S but not a P. However, notice that we don't find an X in either of these areas. We don't find an X inside either of these areas. So this is also an invalid argument. Now you might ask, well, what about this X here on the line? Here's the thing, the X is not inside this area, okay? It's on the line. So we put it on the line because the premise, sum M R S, didn't actually give us enough information to determine which area, that's an S and an M, that X would go inside of. That's why we put it on the line. So it could be that it goes in here, or it could not go in there. So because it's ambiguous, we put the X on the line, which means that we don't actually know if it's actually the case that there is some S that are not P, okay? Because we could have that X fall inside that area that's an S, P, and an M, okay? So this is an invalid argument, okay? Now let's look at truth value analysis. So here we have the statement, the major premise, some P are M, and P's are lizards, and M's are reptiles. So it states that some lizards are reptiles, and this is actually true, okay? So the major premise is true. And the minor premise, some M are S, and M is reptiles, and S is cows. Some reptiles are cows, and this is actually false, so the minor premise is false. Okay, so here in this argument, we also have an unsound argument. Okay, in this case, we have an unsound argument because we have invalid reasoning and one of the premises are false. Okay, so there's a failure in both logical analysis as well as truth value analysis. Okay, so that's how you evaluate standard form categorical syllogisms using the Venn diagram. Okay, the Venn diagram is specifically used to evaluate the reasoning of the argument. Okay, and then you have to separately do truth value analysis. And then when you do the argument as a whole, you bring truth value analysis together with logical analysis. Okay?